In this video, I'll go over the sample set for an interlaboratory study with the microscale combustion calorimeter. The samples come sealed in individual plastic bags. It's important that you take efforts not to contaminate the samples since the sample size required for the MCC is only a couple milligrams. Moisture and other contaminants from your fingers and even breathing on the samples can add additional mass that will increase the errors in the results. So leave the samples in their bags until you're ready to test. The set consists of 6 samples. Polyurethane, which comes as chopped pellets, polypropylene, polystyrene, polycarbonate, and polyphenylsulfone all come in sheet form, and then there's an aircraft phenolic that comes as cured thermoset resin chunks. I'm going to go over the sampling of all the different types here, which breaks down to 3 different types. We have the pellet form, which is similar to a polystyrene video I posted earlier. We have the sheet form, which all 4 of these samples will be tested similarly once the protective films are removed. And then we have the thermoset resin, which I'll go over how to do that one as well. Polystyrene and polyphenylsulfone both have protective films on both sides of the sample that need to be removed before sampling for the MCC. The other 4 samples, polyurethane, polypropylene, polycarbonate, and the phenolic resin, can be tested as received. If you're not 100% confident in your sample handling abilities, then now is the time to put on some gloves. All right, once you put your gloves on, you don't want to touch your face or any dirty surfaces because you could potentially contaminate your sample, defeating the purpose of putting on the gloves in the first place. All right, we're going to start with polyurethane. These pellets weigh about 40 to 60 milligrams a piece, so you could probably get all of your replicates from one pellet. So just like with polystyrene in my other video, I'm just going to grip the sample with some tweezers and cut it in half. Now this polyurethane is a little softer and easier to cut than the polystyrene. So I'm just going to do that again. All right, now we should start getting samples that are about the right size. This is about 10 milligrams, so I know if I cut some of that off, it'll give me a sample that's in the range that I want. All right, 10.7. So I know I want to go a little less than half to get about the right size sample. So I'm going to go ahead and cut that. I'm going to check my weight. Okay. From there, I do my procedure for testing the actual sample. First, I'll make sure the balance is zeroed. Then I add my sample cup. All right, and then I'll record that mass. And then I add my sample. Try to get it right in the middle of the cup, because that's right above the MCC temperature sensor. All right, I'll record that weight, and then I get the sample mass by difference. Another way you can do it is to make sure your balance is zeroed. Put your sample cup on there. Wait for the balance to stabilize, and then hit the tare button after you record the mass of the sample cup. And then after that, you can just add your sample. And it reads out the mass of the sample directly. And I'll weigh the cup at the end of the test if there's any residue to get a char yield. So here we have polypropylene. It's a 1 millimeter film. And with films, I like to take the sample and just cut slivers off the end. And what I'll do is I'll cut the sliver along the edge I'm going to sample from, and I'll discard that first edge. So we have a fresh, clean sample that we know wasn't contaminated from the cutting process. So I'll take that and then I'll cut some thin strips out of it that I'll weigh on the balance. Okay, this one's about 12 milligrams. So from there, I'll take the sample and I'll cut what I think is a couple milligrams. Now with polypropylene, the heat release rate is pretty high, so you only want about a 2 to 2.5 milligram sample. Okay, that looks pretty good. After I'm done getting my sample, I'll put the rest of it back in the bag to avoid any contamination. All right, next we have polystyrene. Now, polystyrene is one of the samples that has a film on both sides that has to be removed. So it's a transparent film. Ooh, it came off easy on that side and on that side. So I only peel back enough so that I can remove the sample for testing. I leave the rest covered in case I want to do some testing later. Again, similar to polypropylene, I'll shave off the outer edge to remove any contamination from cutting. And then from there, polystyrene is pretty brittle, so you can either take it and break off pieces like that, or you can try and cut slivers, which ends up shooting it across the room. So with this one, just kind of hold it down and cut off little chunks. And from there, same procedure. I just look at the balance to get an approximate weight. All right, that one's way too big. So from there, I'll just cut it down until it's about the right size. Getting closer. There we go. Next we have polycarbonate. Polycarbonate is supplied as a very thin film that you can cut with scissors or a razor blade. Make sure your scissors are clean and free of debris before letting it come in contact with the sample. Again, I'll cut off a strip, the edge, to avoid contamination, and from there I'll weigh the strip that I cut to get an idea of about how big a sample I'll need. All right, so I can get over 10 samples out of that strip I just cut. From there, just cut off little pieces, trying to keep them on my cutting board. Okay, a little big, so I know I just have to trim a little bit off to get that in the right size. These samples can also be cut with a razor blade. Next we have Polyphenylsulfone. This one also has a protective film that needs to be removed. So for this one, I just look for an edge that already has the film kind of peeled up. And I'll grab some tweezers and I'll just kind of help it along to pull it back. And I'll go to the other side and do the same thing. All right, once you get the film peeled back, the rest of the sampling is pretty easy. From there, again, you cut your slivers, discarding the first one, and then weighing it to get an approximate idea of how big your sample is going to be. All right, so I know I got plenty of sample here. Again, I'll just cut pieces of it off. Okay, we're in the right ballpark. Lastly, we have the phenolic resin. It's thermoset resin chunks supplied in a little vial. There's all kinds of different shapes and sizes, so you get different size chunks. See how much one of these bigger chunks weighs? All right, around 30 milligrams. I think I put around 200 milligrams per each vial based on the limited amount of the material I had to start with. So for this one, I'll use the sample cup. I need that so that it contains all the pieces. And I want to try and keep the minimum number of pieces to get me the right sample weight that I'm going to use for my test. So I'll tear my pan. All right, so now anything I add is going to be sample mass. So this, I like to hold it down with the tweezers, and this is very brittle and fragile, so pieces can go flying. All right, so I'll get a couple smaller chunks. I'll put one of the larger ones in there. Oop, doesn't fit. How about the largest one that'll fit in the pan? And then I'll get an idea of what it weighs. Okay, pretty good. So from here, I'll get some smaller pieces and add it directly to the pan. Typically, I like to keep it under 2 or 3 chunks. All right, once I get a sample that's about the right size, I'll take it off and make sure all of the sample is in the cup. Now these thermoset plastics are very brittle, and when they heat, they sometimes crack and pop pieces of the sample out of the sample cup. So when you test this, make sure to check out the sample flange on the MCC to make sure there's no chunks of material that exited the pan. All right, so once I'm pretty sure all the sample is in there, I'll go and get a final weight that I'll enter into the MCC.